So this section has nothing to do with slope fields again, so that's partially why I put slope fields to the end. Section 4 is taking section 1, where you were given differential equation sentences and you're supposed to work with them, and then it combines with section 3, which was separation of variables. And so it's combining both of those, where you're going to be given phrases, sentences, and then you're supposed to find the general solution, or, as we move along, particular solutions. And these are more practical ones, like these are ones where you guys have used the formulas before, because you were just given the general solutions in pre-calc. So now you would be given the initial, where it came from, and shown how to get the general solution set. But the worst part is the very beginning, because it feels like it's something made up. So all of growth and decay. So that encompasses a lot of things. Radioactive dating, Newton's law of cooling. I imagine it's Richter scale, decibels, all that kind of stuff. Those are all exponential or decay. They're all based off of the fact that how much you have currently affects how much it changes. And if you write that out as a sentence, it feels like it's just kind of like not a real thing. So this is how it's phrased here, but on the AP test, they usually will phrase it, the rate of change of y is directly proportional to y. And this is how you write that. So the rate of change of y, directly proportional is multiplying by itself. And our goal is, by the time you're done with the particular solution, we're going to have to figure out k and figure out c, because they are different constants. The k is like how much proportional it is, whether it's double, whether it's triple, whatever. The c is a constant that is added on that you don't know what it is until the end. So we're going to have two different constants we have to find out. I absolutely can do number 1 with you if you want. Like, should we go through the fact of how to actually solve this? Okay, so we will do this once. And then you are allowed, whenever you are given the phrase that says that, you are allowed to immediately go right to the general solution. You don't have to prove it each time. Okay, so dy dt equals ky. If I separate the variables, there's no t's on the right hand side, so this essentially just stands for a number. We integrate both sides. This would be ln of y. So just a number, if you integrate it, would be kt. And then we are going to add the constant at the end. And this is pretty much exactly like the one we did yesterday, if you remember it. It was the one in the notes where c will be a multiplier. So, no, I was about to say take it out of natural log form, but you guys do it like that, which is still correct and okay to do. But this will turn into absolute value y equals e to the kt plus c, which we are going to rearrange into e to the c times e to the kt. And then I'm just going to do this in one step so that I don't have to keep rewriting the same things. Taking off the absolute value makes the other side plus or minus. And then the e to the c is just a number, so we call it c, and the c will absorb the plus or minus. So essentially, if you are told the rate of change of y is proportional to y, which is usually how they directly phrase it, you're allowed to go straight to this to begin the problem. So it's the general solution. It feels like it should solve nothing. I can't remember if it's Algebra 2 or Pre-Calc. Which class did you guys do PERT? Continually compounded interest? Both of them? Oh, okay. This is where they came up with PERT from. Principal would be the amount you start with, e to the power of the rate times time. So this is literally where the PERT formula came from, is the amount of money you have will depend on how much money you currently have. The amount of interest you make will depend on how much money you have. So it came from this layout. They just call it PERT so that the letters make sense to you. They're not gonna call it CEKT. Okay. Oh yeah, here we go. The second that sentence is written, I don't have to solve the differential equation because it's the same differential equation. So I am allowed to immediately start with CEKT. And then normally we only had a single C in a problem, and so you were given a pair of numbers to figure out C. Like you were given like X is 0, Y is 5, something like that. For us to be able to figure out C and K, we have to have two sets of numbers. So we kind of find them one at a time. The C value is super easy to find if you have a 0. So an initial value. Because if you put 0 in place of t, e to the 0 is 1, and so then that just basically eliminates it, and then c is your starting value. So most of the time, this will be the starting amount as long as this is the whole formula. Newton's law of cooling will have more things to the formula, and so then that's not the starting amount. Off the top of my head, I think Newton's law of cooling is going to be the only questions that's not the starting initial value. So if I put 0 in place of t, I would get e to the 0, and then it would say c equals 3. So if I know c is the starting amount, and we're told that at time 0, y is 3, I can put that in. And then solving for k is traditionally annoying because it's always going to be a ton of decimals or just not a nice number. Sometimes these are on the non-calculator questions, so you have to use exact answers. Most of the time they are on calculators, so then you have to use a lot of decimals. So I'm going to take my second pair of numbers. And that second pair of numbers is going to help me figure out k. So I'm going to put 6 in place of y. Two in place of t. I got your test too. Colin, thank you. You guys are very good friends reminding me it's him every day. Do you want to solve this one? Do you want somebody else to solve it? Sounds good. Who's going to be? Tyler, how do we solve that?
If you split it up, there's a k times 2, you can split that up.
I'm not positive what you're telling you.
Didn't we do that yesterday where you can like make that into a plus?
If there is a plus there, you can separate that.
Then I have
Okay. Oh, that was it? You're not gonna try anything else?
Just get the 2 over.
Okay, no, the 3.
3, yeah, that's what I said. So it'd be 2 equals e to the k of 2.
Good? I'll move up here.
And
How do you solve for a power? Oh, why am I writing K2? Isn't that like a ski brand,
then plus
K2?
e to the 2.
Or no, that's a mountain, isn't
K2.
it? Okay. How do you solve for a power? I didn't hear anything you said. Oh, I thought I heard you talking, I just didn't listen.
Is like 2 equals e to the 2 plus e to the k? Can you do that?
What?
Can you split them up?
That's what you just said over here.
You can't do that.
It's the same thing. Like, the only difference is the 3's not there. You can split up the power if there's a plus sign. So that actually doesn't happen that often.
Oh.
Go ahead, you can call somebody else, that's okay. Oh, that's a no? Oh, there's only one method to solve for a power, or an exponent. Natural logs. Yeah, natural logs, that's literally why natural logs were invented, was to solve for powers. Okay, so I'm gonna take the natural log of both sides. I guess theoretically it doesn't matter which logarithm you take of both sides, but we pick natural log because we have an e. Exponents from natural logs can go up front as a multiplier. ln of e is 1, because this means e to what power is e. So that is 1. And so k is ln of 2 over 2. If I recall correctly, didn't your pre-calc book tell you how to do the exponent multiplier for half-life? Didn't it tell you ln of 2 over something over half-life? I remember everybody in previous years tries to use that as a shortcut. Well, if you guys don't remember it, that's even better. Okay, so we figured out k. If you want to make this a decimal, make sure you use all the decimal places the calculator gives you, because most of these questions we get involve larger numbers, and so the decimal that's in the exponent will change your answer a lot. And so on the AP test, your final answer has to be accurate to 3 decimal places. And so I know some of you have had sig figs and probably hate that a lot. But that basically means use as many decimals as you can to get your final answer correct. I'm just gonna leave it as ln of 2 over 2. Okay, so I take my equation and now I fill in k. And then I think the problem up above asks me one more thing, doesn't it? Value of y when t is 3. These problems take forever, as you're seeing. There's generally always 2 things you have to do to even figure out the equation to use. And so we put 3 in place of t. You plug that in your calculator, or just leave it as an exact answer. 3 halves ln 2. This would be the exact answer. If you want the decimal, then it's got to be calculated. My guess is you as students probably love these questions or hate these questions. Some students like these because they're kind of different all the time, but yet they work well together, they like have an order. Some students hate them because they just hate all of these steps, all the decimals, things like that. It's just kinda how it goes. I don't know, you probably may have questions on parts of this that maybe you didn't ask yet.
Like, you put in the 0 and the 3 and then you put in the 2 and the 6. But then why do you put in the 0 and the 3 and then like bring the E2 back?
Whoa, okay. So the 0 and the 3 to start with is for, if you have a 0 value, that'll help us find the starting value, or I should say, that'll always help us find C. So that was the 0, 3 was to help us find the 3. So this is like stage 1. And then now we still have a variable constant left. So that was the second piece of numbers that they gave us, the 3, 6, I think it was. And the only reason we used the 3, 6 was to figure out K. And then once you figure out K, that's like second stage. And then we can actually do the question they asked us. And that usually will always just be to put in one of these two numbers. It's not always gonna be the key. Okay, but what, you were saying something about like combining them?
Yeah, I was just confused that like the E to the 0 became a 1 and then the E was wrong.
It's like us using the same formula repeatedly. And then once we find answers, we put those answers in and keep using the same formula, but like a more correct version of the formula each time, I guess. So yes, you do repeatedly keep using it. So you're generally gonna use the same formula 3 times. It's just each time you'll add a number. Is that kinda how you were asking it?
Yeah.
Okay. Do you guys feel like you know this enough to be able to try one of these? Okay, I think the one right below was somewhat similar, if I remember right. No, it is not. Part of me wants to do this one tomorrow, because it's different. It's actually easier. I just don't want to confuse you with the process we're doing. This one, I think, this one didn't, oh, yes, no, this one's okay, but it's written differently, which is all of them. There's two types of these questions. One type of the question will give you an initial amount. Those are easier. One type of question will not give you an initial amount. Those are a lot more work. I believe that's the one right below this. It's like bugs or something. Yeah, that one's tomorrow. This is the section we get 2 days for, which will work well because these are slow. So try this one. Do you want me to help you start it? Okay, so, you know what, it doesn't even put in the phrase. I'm pretty sure I remember on the AP test they will always use the phrase, the rate of change of y is proportional to y. Maybe a different letter, but they'll always use the phrase. The exponential pattern of decline is that. So it's telling you that you can use this to figure it out. 530,000 in 2008, this would be year 0, 530,000. It doesn't matter that it says 2008, that's the first number they gave us. If you wanted to use 2008, you could, but then it becomes a more difficult problem like down below, which you'll find out tomorrow. This one is 2 years later, so this one would be the 0.2386. It would work both methods. This one is just easier because you have an initial amount. So try to find the answer for 2013 from those two numbers.
And then basically X, essentially like the 2 would be the time, and then.
The year would be the X would be the years.
Yep, and then the Y would be.
Oh, actually, I didn't even write X, but yes. Correct. In this situation, time, so for us, the years.
Yeah, yeah.
Y would be the amount. Correct. Yeah, I guess I never thought about that. Okay, what's 124? We're good. So they're calling it a pep fest. I think they're calling it that because they don't care if you're there or not.
Perfect, that's all I needed to do.
That's what I assumed you were asking.
Yes.
Yes, there is no, it would be ridiculous to try to do it otherwise, because not dunk tank, the polar plunge is on the front sidewalk, like by the parking lot.
Oh, it's outside.
Yeah,
Oh.
so it's not gonna be in the gym, because they don't wanna ruin the gym floor. So having it outside would be kind of ridiculous to
Take it down, something.
not expect some to just go straight past.
Perfect, that's what I'll be doing.
Don't tell me.
Oh, yeah, you didn't hear.
Correct. Not that it's recorded either.
Right. Some kids have been watching this like 2 years.
But I think it's actually allowed, so I think that's the way pet fests have always been done. Max, give me a number higher than yours.
34.
Wait, isn't that the number you called in yesterday?
No, we had 33. Oh, wait, 35.
Too late. Audrey, how do you feel about doing part of this beginning of it?
Sure.
Okay.
Yeah. You want me to go up there?
Yeah, we're being brave today. Okay, so our first goal to start with is to find C. Usually it's easier to find the multiplier on the front than it is to find the exponent, so we try to save the exponent till last if we can. Oh, okay, before you go, so then, once you figure out C, make sure you rewrite the equation with C in it. So we've basically refined our equation to now be 530,000 e to the kt. Also, if you're crazy annoyed at writing the thousands, you could also drop the thousands from all of those and know that the answer is in thousands. But my guess is most of you are just using a calculator anyway, so it doesn't really matter if it's a big number. Okay, good. Good start. Who's going to help us find the K?
22.
I thought for sure it was going to be 35. Okay, 22. No one. All right, nobody's there.
25.
Is that Lena?
No, it's the very back.
Also,
What?
That's the back.
Oh,
Okay. 27.
is Jason 27?
Yeah.
The noise you made me think it was you.
Yeah.
Whoa, up there. If you haven't written down it, just bring it with. Yep. If you don't, we can guide you a little bit, etc.
What?
You can call on people to do calculations for you if you need them to do that. How do we find K now that we found C? Actually, you weren't even here to watch this on the first one. I'm sorry, I didn't think of that. You came in right as we were finishing the problem, if I remember right. Do you know how to figure out K, or should we call on somebody else?
I think I'll call on somebody.
Sure. Are you trying to pretend it's not going to be Aiden?
I don't know the numbers, so like this is like actually random.
You could just call the person.
Okay, Aiden.
I mean, the number is just, if some people don't like to be
Yeah.
mean and choose somebody, so they just give a random number. Aiden, can you help him out? He would like some guidance because he wasn't in here for finding K.
Well, we know that you can use t as 2 for the next one, and set y equal to 386,000. It's equal to 500. Yeah, 530,000. Yeah, 530,000 e to the power of k times 2.
Yeah, we basically take our equation that we just figured out C from, and then put the numbers into that equation.
Then do you just like divide these and then like
Perfect.
do LM?
Divide them and then take the natural log of both sides.
Yeah.
Yep.
Then like
So, as a tip, which is super annoying, My guess is this is not gonna be a nice decimal. Did somebody divide it out?
Yeah, point seven.
Oh,
Is it like perfect 0.7?
No.
Oh, so then don't make it a decimal yet.
okay.
You can, like if you're good at using the store feature on your calculator, that worked great here. Otherwise, just leave it as 386 over 530.
Yeah, then like drag that down, I guess, and then like it's like ln, like whatever that is, and then
Oh, yep,
and like
2K.
yeah, ln of e 2k, and yeah, these cancel out, so like
Yep, no, it's perfect.
and like combine.
Correct.
Okay.
No, that's good.
Okay.
I mean, as long as we realize that that circle stands for 386 over 530. Good, no, good. It is annoying to write natural log of 386 over 530 divided by 2, but it will give you a more exact answer than if you had changed it to a decimal, and then, because your decimal is technically rounded. Like, no, let me phrase that differently. Depending on how you use the calculator, your calculator actually stores digits way out farther than it can display. And so if you hit the decimal divided by 2, that would work great. But my guess is most of you would probably write down by hand the 8 decimal digits you see. And that's actually going to be different than just writing the exact answer. The exact answer will work better even though it's annoying to write.
So on the test, we have to plug in K back into the.
I would not do anything with decimals until the final answer so that the rounding will work correct.
We just found K, should we plug it in like that?
K is going to be ln of 386 5/30 divided by 2. Yes. Okay, so now, Jason, who's going?
Number 8.
Is that Foster? Okay, Foster. I didn't have Jason rewrite the equation. I forgot to. But we are currently at y equals 530,000 e to the power of ln of 386 5/30 divided by 2 times t. What number are we going to put in place of t to find how many dollars it would be in 2013? Perfect. 2013 would be 5. It's however many years after 2008. Okay? Did you plug that in already? I'll make sure to write this just for our note, but no, what is it? 386 5/30? What did you get to 3 decimal places?
239,113.373.
Oh, my bad. We're doing money, aren't we?
Yeah, it's
2 decimal places.
37.
Yes. So on the AP test, if it's money, 2 decimal places. Everything else 3. Now that I say that out loud, I don't think they ever specifically say that. Maybe they do in the directions. But the actual directions of the test, they always say 3 decimal places. So maybe the money questions, it will say to the nearest cent or something like that. Okay, good. If you had converted this to a decimal, my guess is this might have been a different penny. Because when you're working with the big numbers, the rounding doesn't work as great 3 decimals out. Like you have to have a lot of decimal places for it to round correctly. Okay, I'll stop there for today. Tomorrow we have 2 types of problems to do. This same style, but we're not given a 0 to start with. and then radioactive decay. I don't think there's any Newton's law of cooling in the notes, if I remember right.
Oh, you mean analog? Yeah, I couldn't read this.
Oh, right there. Okay, 3 types of problems tomorrow. I was gonna come up with one on my own if there wasn't any in the notes.
I can, I just.
They're all the same style question though. Okay?